Okay, let's talk now about the clearance definition, another clearance definition of the drug if it's model independent definition. Okay, which as we mentioned in the previous class or previous recorded video of this class, that when we are talking about model independent, it means that there is nothing as assumption that I need to assume or have as an assumption of that equation related to certain model as one compartment or two compartment or whatsoever. Okay, so again, it's model independent or non-compartmental definition of the clearance because we are using for it dose over area, total area under the curve. Okay. Again, for the dose, it's the given or the initial amount, it's the given dose for total area under the curve, which is the, if you're talking about CB versus time, we have this for IV bolus or other profiles for other route of administration. We will keep it for IV bolus for now when we are talking about 0 to infinity, okay, which means that I will have it from 0 to infinity area under the curve, which is the total area under this curve of CB versus time. Okay, so if we consider about or we ask ourselves, do we have any assumption to determine the area under the curve, total area under the curve? No. So that's why we have no assumptions to take into consideration before having this equation or this a clearance calculation. That's why we call it model independent or non-compartmental definition of the clearance. So now we will talk about the way how to determine area under the curve. Before I just told you to keep it as simple as we can determine the clearance from knowing the dose and total area under the curve. Okay. For now, I will show you how we can do the calculation of area under the curve. First of all, of whatever we know before, when we determine area under the curve, whatsoever the curve that we have, if you remember from the math that or math principles that you already have in school, whatever the curve that you have, you can determine area under the curve, right? Whatever that you are drawing, y versus x, right? And this was by doing integration of the function that you have, right? If we are talking here about the function as y, you need to integrate from certain time to another time. Let's keep it as time 1 2 times 2, let's say. If you want total, it will be the integration from 0 to infinity. If we go back to the profile that we have of concentration versus time for on rectilinear, we need to use rectilinear profile. And again, ask yourself why. And again, this is the linear determination of the area under the curve. So we need to use rectilinear profile in which the profile that you have would be as the when you are draw the real number of concentration versus time. Okay, and we need again to determine the total area under the curve, which is from 0 to infinity. Okay, if we are talking about or using the same principle that we know, so to determine area under the curve from 0 to infinity of IV bolus route of administration would be the integration from 0 to infinity to the function that I have, right? Which means that I need to integrate what is the function of this profile. Or in other words, what is the model equation of this profile? This would be the equation or the integration from 0 to infinity to CB naught exponent, right, dt. Okay, So we need to do the integration of the equation that we already know, that we used already for our model equation. And then you need to integrate. And when you do the integration, you can find that 0 to infinity or total, or in other words, we call it total area under the curve because it's from 0 until the infinity would be the initial concentration over the elimination rate constant. Okay, so again, if we are using the math integration, this would be CB node over K. And again, we are talking about IV bolus, and we will see what we will have if we are talking about extravascular or oral. This would be equal to the dose over VD multiplied to K, okay? Because this is dose over K, okay? Which would be equal to the dose over total clearance, which what you already know, okay? That the clearance could be used to measure area under the curve, or area under the curve could be used to estimate the total clearance, okay? But we will do something else to estimate the area under the curve, and we have different ways to do so. One of the simplest way that is usually used in the educational setting is the trapezoidal rule to determine area under the curve. From its name, it's trapezoidal, so it means that I need to use what we call trapezoids. And the trapezoids, or the trapezoid, is this shape, geometric shape. Okay, if we consider that it's not shown here in the right way, let me see if it's, oh, we are losing the multiplication here, but it's fine. Okay, this is the trapezoidal shape, which means that if we are talking about A, B, one base, D, C, another base. Why we call them bases? Because they are parallel to each other. Okay, the length of this is A, and the length of this is B. Okay, so A and B as the lengths are the lengths of two bases that we have of the trapezoid. Okay, so to determine, and the H here is the height of that trapezoid, because it's making a 90 degree angle with that one of the bases. Okay, so again, to determine the area of the trapezoid, it would be the sum of both bases over 2 multiplied to the height. So the area of the trapezoid would be a plus b, half of a plus b multiplied to the height. This is the area of trapezoid. Why we will use the trapezoidal method, or how we will use the trapezoidal area, that's why we call it trapezoidal method. How we will use the area of the trapezoid to determine area under the curve. What we will do is we will have our profile. Let's draw a large profile, concentration in the plasma versus time. Okay, CP versus time. Okay, if we have this profile, let's say this is the last measured concentration. Okay, we need to divide the area under this profile into different trapezoids. Okay, again, those are trapezoids. Usually, to make this method, which is the trapezoidal method to determine area under the curve, to make it accurate, we need to have as much trapezoids as we can. Why is this? Can you think of a reason why we need to have as much trapezoids as we can? Because if you go to the shape of the trapezoid, it's a geometrical shape that looks like this. So if we take one of those trapezoids, let's use a highlight, it may be easier. Okay, let's go with this trapezoid. Okay, which is the first trapezoid that we have. Okay, if we take this trapezoid and I want to draw it here, it would be this, 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 and this, right? But just a smaller, like simplification of it, smaller version of it. Okay, if we take as frequent as we can as trapezoids, as frequent as we can, or as more as we can from the trapezoid under the profile, this part of the profile would be what? Linear. Otherwise, if I take it from here to here, let's say, it would be curve. So it wouldn't be a trapezoid anymore. So to be accurate, we need to take as much trapezoid or divide the area under the curve to as much trapezoid as we can. Okay, let's go back to, and again, we need to have it on rectilinear for the method that we are using. Let's go back to this trapezoid. If we are talking about um, concentration, this is concentration 1, this is concentration 2, this is T1, this is T2. Okay, this is concentration 3, this is concentration time 3. So let's go with the area of this trapezoid, which is the second trapezoid. So the area of the second trapezoid would be equal to, we said, half the sum of two bases multiplied to the height. Again, the bases are the parallel edges of the shape that we have, which is this and this, which would be half CB2 plus CB1 over, I already mentioned, over 2 multiplied to the height, which we have it here, which would be equal to T3 minus T2. Okay, so again, you will have the length of this, which is CB2, plus the length of this, then take the half of it, then multiply it to the height, which is T3 minus T2. This is the area of the second one. You can determine the area of each one of them. Okay, let's say this is 16. Okay, so the area under the curve from 0, which is here, 0, until the end, which is here, we call it T last, as this is CB last measured, would be equal the sum of all area under the curve from, let's say, Tn minus 1 to Tn, and this is from 0 to the last measured time, which is this. Okay, so you can determine the, let's say, the area under the curve. You can estimate it using all those trapezoids. So we can measure or estimate area under the curve of all of those trapezoids, okay? And then take the sum of all of them, you will have 0 to T last. Did I finish? No, because when you have area under the curve from 0 to infinity, you need to have it from 0 until infinity. In this profile, I still have this part, which is from t last to infinity. I will enlarge it here, okay? So if we are talking about CB versus time, we had all of it before, okay, until we reach, and all of it before, until we reach the CB last, which is the last measure, with the T last, which is the last time that we measure concentration on. So we still need to have this profile, okay, or the area of this part of the profile, which is until infinity, which we can measure it. We can't measure it experimentally. So from CB last or T last until the infinity. So again, if we go back, this would be equal area under the curve from 0 to T last plus area under the curve from T last until infinity. Okay, this is we used a trapezoidal method or trapezoidal area to determine it. We still have this. We need to do an integration, as we mentioned before. We need to do, let's write it here, an integration from T last until infinity to the CB certain time to the function, right? This function is the same as we know, which is CB naught multiplied to the exponent of the power minus k multiplied to the time, okay? But if the overall profile, if we integrate the overall profile, it gives me CB naught over K, as I mentioned here. What would be the case if I integrate but from CB last rather than CB naught? This would give me CB last over K. So after you do the sum of all of the trapezoids that you have, you still have area under the curve from T last until infinity, which would be equal to CB last over K according to whatever we know. Okay? The last thing to mention is the unit of area under the curve, which I mentioned it already before in the calculation class of the IV bolus. If we have area under the curve that is equal to dose over total clearance, this is dose of mass, this is volume over time. So this is the unit of the clearance, or could be just mass time over volume, or mass volume reciprocal of the volume multiplied to the time, which I already mentioned it here. Okay, it's mass reciprocal of the volume multiplied to the time, or mass hour over volume, or mass time over volume. And I will stop at here to make area under the curve a separate part.